Welcome back to another episode of Site Visit. We are in Back Bay. We're going to check in with Tim. So last time we were here, I had talked about the subfloor in the basement, or the lower level, and how we were going to utilize that subfloor as well as a coating on top of it to prevent moisture from making its way up into the living space. Let's go downstairs and talk about that a little bit more, because I made a mistake and I miscommunicated something. I actually missed a really critical detail. So we're going to talk about that a little bit more in depth, how we corrected it and how we got to that solution to make sure that we were in fact going to prevent moisture from making its way up into the living space, not just prevent moisture from making its way into the hardwood floor. So a lot of comments that you guys had made was about the fact that underneath this wood floor was soil. And a conversation that Tim and I had off camera before we had started this job was my mind was wrapped around hardwood floor, which is something you and I talked about. Yeah. Preventing moisture from making its way into that hardwood floor was my main concern. And that's why I had said, hey, let's get new subfloor installed. Let's make sure it's super sealed and make sure we put that blue moisture guard on top of the subfloor, again, to prevent moisture from making its way into the hardwood. What I failed to think about, and which you guys had commented on, which first off, this is why we do these videos. We love the feedback. You guys were like, hey, stop, wait a second. What about the soil that's underneath? And I immediately was like, no, the soil's pretty dry, and realized that that wasn't really the right mentality. So I had called Tim basically at that moment. I was like, hey, Tim, pause for a minute. I want to think about this. I want to figure out the best way to approach this. And called my buddy Steve Bazek and had a conversation with him. And basically what we came up with was, hey, we need to prevent, let me back up from the technical side of it. Even though the soil is dry, the reality is that moisture was probably at some point transfers from that soil up into this living space. And previously the subfloor was cut up, a lot of holes in it that we've since patched, and moisture was probably making its way into this space and then balancing out. What we were going to be doing, what we would have done by sealing up this subfloor and not having anything on top of that soil was create a microclimate, meaning that moisture, even if it was a liter of water coming out of the ground, would have came up, hit the wood, found the insulation, found a nice warm place to hang out, and slowly rot that wood over time. So what we've done, Tim, why don't you give us a quick rundown of what we have done underneath this floor now, and then I'll kind of allude to or talk about the technical side of that.
So we paused, like you mentioned, and decided to spread 6 mil poly underneath the floor, covering as much as we could.
Right, and that's a key point to what we're talking about here. Is this floor is really chopped up. Yeah. We have this odd. Again, guys, this is a brownstone in downtown Boston. There is common space that we don't have access to, and frankly, it's kind of partially wood floor, partially concrete floor, and so. Like Tim said, being able to spread a 6 mil poly on top of that soil and covering as much as possible was our best practice here. Yeah. If we were to gut this place and not have the constraints of dealing with an existing mechanical room or common space, we would have gutted this entirely and started from scratch. We didn't have that opportunity to do that. But that moisture making its way up from the soil is not, if we can prevent it from coming out of that soil and making its way to the wood framing, then we're doing our job. And frankly, if we can cover as much of that soil as possible, we're doing everything we can to prevent as much of that moisture. One of the questions I had asked was, well, isn't it like air? Meaning, if I was a water molecule, pretend maybe make me into a water molecule, Doug. But if I came out of the soil and saw plastic, I'm not going to then search around for a void in the plastic. I'm just going to hit that plastic and then fall back down into the earth. So the minor areas that maybe aren't covered, I think you guys did a pretty good job covering, if not everything, pretty close to it. But if there is a void, it's so minor, and if you take that 1 liter of water spread out over this entire, over 1,000 square feet here, it is very minor. But in addition, we were talking about adding something else as well, right?
Yeah, trying to circulate the air, trying to either condition the space to the inside or just kind of relieve the air that's underneath and either get it outside or, what did you call it? pressurize or
But yeah, we talked about
passively seep into this space.
Right.
So those are kind of our options, either passively letting it kind of breathe with this space or getting the air outside.
All the way out. So ventilating that crawl space. So going back to the whole microclimate, if we are creating a microclimate and we're locking it in, it's really, that's the worst case scenario where ideally you do want to ventilate your crawl space. So like you said, there's two ways to do it. We ventilate it to the outside, which we could do with a mechanical ventilating fan, and then exhaust it out to the outside, and then you're pulling air out of it and exhausting it. The other option is to encapsulate it within the envelope. And if we're, basically pumping one end of the crawl space with conditioned air and letting that passively come across and then come out of a passive vent. Again, passive meaning that air is just kind of trickle through and then eventually make its way out. Because if you're pumping air down there, you're essentially pressurizing it.
Yeah, we don't want that.
We don't want pressure. Yeah, we don't want to pressurize it. So letting it escape back in the system, now you're effectively creating this circular movement. So again, that was something we wanted to address. The comments, the suggestions. Thank you to Steve Basic for walking us through kind of the best approach here and thinking about in the future, one of the things, if we had the opportunity, and we weren't dealing with common space that we really can't impact, we would have just stripped everything out of here and started with a full continuous vapor barrier.
Yeah.
But all right, enough about that. You guys have made some good progress. Let's start down here. Besides the subfloor is installed, but you guys had some steel going in. Walk me through that.
Last week we had Ryan from RMS, him and his guys came out and installed the 2 pieces of steel on either side of the stair hole that I think we talked about last time.
Yeah, we had talked about these brackets, now they're installed. So how did these get installed?
They're drilled and epoxied and bolted in, pretty much self-explanatory as you see.
Sure.
8-inch embedment, so they go in 8 inches, epoxied in with the screen. And then after everything sets up, tighten those bolts down, they're rock solid. So
that beam is essentially wall to wall. How did we get this thing in here?
So it's a 2-piece beam. You can kind of see this was the welded connection. It's a full pen weld, so it basically turning it back into one beam as it goes in and they weld it back together.
Full pen meaning full penetration. So
exactly.
that steel is essentially beveled all the way to a point, and that's filled with weld, either, I'm sure, in multiple passes, not just a single pass.
Yeah.
Why is there a bolted connection as well?
The bolted connection was assisted with the installation to keep everything in line. You could straighten, you can shim. It was approved by the engineers as a way of just kind of making the install quality be there and not having to temp support each side.
So if you guys can envision, if you have 2 walls here and say it's, 17 feet?
18, but yeah.
Okay. 18 feet, and you have a beam that's 18 feet. To get that in, you could do it if you had nothing around. We got a lot of beams, a lot of pipes, we have framing, we have wiring to work around. So essentially what we're doing is you're installing two beams like that, and you're lifting them up in the middle and essentially, creating a V back into a straight, bolting that together.
Yep.
And now it's in on top of your brackets, bolted together, it's in place, and then you're doing the full pen weld. So you have one here, and then where's the other one?
It's a few feet this way.
Okay.
This was trying to avoid any of the shutdowns and costly work with redoing the plumbing and electrical that kind of jockeys around that stair hole. This was an option that the engineer came up with to avoid that whole situation, that whole mess.
Sure.
Trying to remove that joist with all the stuff around it and trying to get new beams around all that stuff. Just come back to a clear bay that works for us.
Right.
And install this beam over here because this one doesn't carry any load from the building necessarily. This only carries the header of the staircase.
Right. So I want to go back to something you said. Why is it important that we're avoiding shutdowns in electrical?
For a lot of reasons, but mostly because we did this in the wintertime and we don't want to shut down steam and have to shut down plumbing repeatedly. We have those shutdowns coming and we'll plan for them, but we want to minimize them.
But I guess where I'm going with this is, why do we want to minimize them if we're in a construction zone? We don't need that stuff.
Because the rest of the people in the building certainly do.
Right, and I'm calling attention to that because a lot of times people forget about that, and when we're doing that, and these are the challenges that we face, especially in a multi-unit building, is we're not just thinking about how this impacts this space, but how it impacts the 4 other homes in this building. So moving the beam over to what works for you as a clear span, makes sense. We're upsizing the steel in order to accommodate it. Again, you have your bolted in full pen weld here, you have your bracket on the wall, and then you have one actually buried in this common space as well in order to support it. But you just talked about your stair header.
Yep.
So that stair header, if I am right, I believe is also set back from the actual upper landing. Is that right?
It is. The landing cantilevers in 2 spots, so it cantilevers out for a small landing that projects over the staircase as it comes down to give you your ceiling height as you come down the staircase. So you're looking at, one for the landing, and then the actual tread kind of coming into the stair hole where you would walk up. That is also a cantilever. So 2 different sizes. This one's like 2.6.
Yeah.
The one for the landing, and the other one will be about 9 inches.
So obviously in a much different scenario, this is all existing will be taken out. But what Tim's saying is that we're going to have a beam closer to back here to catch our first step. But as this stair will start here and U-shape down, and as you work your way down, that opening actually comes this way on this side of the stair, and this landing here actually will be cantilevered off of your stair header.
Yep.
So that was a detail that had to be worked out with the engineer as well, because when we started, it was drawn, it was designed, it was beautiful, but there was nowhere to support it.
Yeah.
So let's go upstairs, because I think it's easier to understand what we're dealing with up here. But you also laid out some reference lines to get this staircase. While it's a round stair, it has to be a perfectly square hole.
We did.
Let's go up there. Here's our reference line, right here, dead center of the window. Walk me through how you establish this line.
It's dead center of both windows. So both sides of the building have the same bay window configuration. So we're center of the bay windows on each front and back.
Yep.
And that is the reference line we use to maintain our parallel.
Yep. And then just for a quick tip, clear matte finish, spray paint. You snap a line with your string line, not your string line, your chalk line. Cover it with matte clear, and it won't be brushed away when you're sweeping up.
Yep.
But you have one this way as well. How did you establish this one?
So this one is actually just a math problem, I'd say, almost similar to 3-4-5.
Okay.
Just pull as far as we could, 10 feet one way, as far as we could the other way. Pull your diagonal, create your intersection, and snap that line the other direction.
So what Tim's saying on this 3-4-5 method or 6-8-10 would be when you measure 3 feet in one direction and 4 feet in the other direction, we know that that diagonal has to be 5 feet in order to make this a true 90 degrees. When you're dealing with a larger space, you can do a larger increment. So you can go up to 6 foot, 8 foot, and then that diagonal is going to be 10. Again, now you know that you're establishing a 90-degree corner here, which, what are we using these lines for?
So the reference line, the long one in the middle, is the one we're using to maintain all the walls parallel on each side. The other line is more or less to get the layout right, because there isn't a lot of walls that we're recreating that are parallel to the perpendicular line.
No, but we do have one wall that was actually framed before we did the layout, which is this wall, which it is a new wall, but it was predetermined.
Yeah.
You guys had found, I think, a slight discrepancy based on this layout.
It is out of square with the reference lines by about 1.25 inches.
Overall, 18 feet?
The entire 18 feet, if you pull to that parallel line, which is square off of our center line.
Right.
It's 1.25 inches out of parallel of that line.
So something that we talked about kind of off camera was, what does that mean for this project? Do we have to move this wall? Do we have to fudge the location of the wall? And these are going to be the give and takes. Just like this floor, it's not perfectly flat. There will be give and takes, but we want the predetermined, what is our parallel wall? What is our square wall? But with the consideration of where this ends up out here is less impactful to what ends up in the stair opening.
Yeah, the stair hole is very important. The stair hole needs to be square. I mean, we've talked about before, but this stair hole is getting made off-site, and we need to create that U-shaped wall, not to mention a nice square stair hole for lighting, and so everything can install down the road. We can't have things being out of square.
Yeah.
So it's something we're going to have to get into.
I think you hit a really interesting point, lighting. And lighting has a way of showcasing everything that isn't right, in a really, really unfortunate way. So in this case, when there's going to be decorative lighting, there's going to be overhead lighting. Like you said, the staircase is being built off-site. It has to be. We have to hit our parameters, and then so the upper section here is going to be a square opening, like Tim said. Then the lower section where the stair actually sits, we actually have a U-shaped wall for that stair to sit against. So all of those reveals and things like that, when I'm not gonna say perfect, but when they're done really great, you don't notice how great they are. It's just this thing that looks beautiful, and it's there. The reveals are consistent. They're the same on both sides. Everything makes sense. But when they're wrong, it's almost the first thing that you see.
Yeah,
it's like, wow, why is that side bigger than that side? And when you're dealing with something that could potentially be 1.25 inches out of square, that's where we have to determine what this wall looks like and what we do on this side. So there's ways that we can actually pad this wall and kind of make this wall work, especially for in here.
Absolutely.
I was actually looking at this when I walked in. This staircase is wonky. Existing common stair that leads up to the other homes in this building. My concern, and I think you can address my concern pretty quickly, but this line here, from where this goes from plumb to angled, over there, increases in height.
Yeah.
What are we going to do to combat that so we're not looking at a reveal that rides up?
Well, we are going to have to deal with the out of squareness in this room also, not just the staircase.
Sure.
But that's what you're seeing, is a staircase that's not perfectly level and also a wall that is out of square with the space.
Right.
So we're going to do our best to take care of all of that. Like you said, the effort that we'll put into it is going to take the same amount of time to do it wrong as it is to do it right.
Right.
You're not going to see it by the time we're done.
Exactly. So whether it's relocating some of this wall, whether it's padding it out, but also there's some millwork here too that will play into effect. But that's something that, obviously working with materia, we want, and these cabinets going, all the way up, we want to make sure that we're dealing with really flat ceilings, consistent ceilings. So it is, oftentimes what we're going to do is we're going to run into things like this on the job where, yeah, we want to get these walls up, we want to get them in place. But when we run into something where it's like, how do we deal with that? It's almost better sometimes for us to get it in place and look at it and figure out what is our best course of action in order for us to get this looking the best in the final result.
And deal with them one at a time. We have plenty of these things going on.
Exactly.
So deal with these problems one at a time. Take our time, get them right.
So you got the steel in. We're prepping for the stair. You have some framing to wrap up. A lot of framing got done up here. What is next steps? What does the next week look like for us here?
So this week is kind of playing catch up. We've got the framers starting next Monday downstairs on perimeter walls. Same process as we went through up here.
And we basically had them pause because of that subfloor issue.
Yeah, there's a combination of issues. That was one of them.
Yeah, getting the steel in, dealing with the underfloor vapor barrier, and probably getting layout done because right before we shot, you guys were just getting that plywood down.
Yeah.
So will you do the same reference line down there?
We will.
And will you transfer this line, basically this line downstairs, so everything, as you step from floor to floor, there's that consistent parallel?
Yeah, the perpendicular line isn't that as important, but definitely center line will be the same.
Perfect. Cool. All right, we'll check in next week when framing progress continues. We'll also maybe give you guys a sneak peek next week at what this staircase is shaping up to be. I know we have some 3D models that we've been working on, and maybe even get our PM Liz on camera. We'll see you guys then.